All right, colliding neutron stars. You guys sent in some awesome articles.
Yeah.
And this one from space.com, Hubble watches neutron stars collide and explode to create a black hole and birth atoms. That's pretty wild.
Yeah, it is fascinating. And it's not just a theory anymore.
Right.
We have images from the Hubble telescope and other instruments that show these events are actually happening.
We're going to dive deep today and find out what happens when these super dense stars crash into each other.
Right.
We'll unpack all the physics.
Okay.
And you're going to be surprised how this affects us here on Earth.
Okay.
So, to kick things off, paint us a picture of what a neutron star is.
Picture this.
Okay.
An object so dense that a sugar cube-sized piece of it would weigh 1 billion tons.
Wow.
That's a neutron star.
Okay.
It's what's left after a massive star, at least 8 times bigger than our sun, collapses under its own gravity.
That's some heavy stuff. Literally.
Yeah.
How does something get that dense?
Well, it all starts with a supernova. The star explodes, and its core collapses in on itself, squeezing electrons and protons together until they become neutrons.
Okay, so now we've got these crazy dense neutron stars, and the article focuses on what happens when 2 of them are in a binary system.
Right.
What makes that so special?
Well, it's not every day you see 2 neutron stars orbiting each other.
Right.
What makes them special is their immense gravity and the crazy dance they do before colliding.
Okay, so these stars are waltzing towards a grand finale.
Yeah.
Tell me more about this dance.
Imagine a cosmic waltz, but with gravity leading the way.
Okay.
As they orbit each other, these stars lose energy, sending out ripples in space-time called gravitational waves.
Okay.
And those waves carry away energy,
Right.
causing the stars to spiral closer and closer and closer.
It's a slow but inevitable collision course.
Exactly. And as they get closer, the dance gets faster and more intense. The energy they release is unimaginable.
I bet. So what happens when they finally meet? I'm picturing a cosmic explosion of epic proportions.
You're not wrong.
Okay.
The collision results in an explosion called a kilonova.
A kilonova.
And it's so bright, it shines with the light of hundreds of millions of suns.
Hundreds of millions of suns. That's got to be the most dazzling light show in the universe.
It is breathtaking.
Yeah.
But it's not just a flash of light. There are stages to this kilonova event.
Okay, let's unpack those stages. What happens first?
First, imagine a massive amount of neutron-rich matter ejected at temperatures, billions of degrees, thousands of times hotter than our sun.
Wow. And what happens to all that superheated matter? Does it just hang out there?
Well, it forms a giant, rapidly expanding cloud of plasma that cools as it spreads outward, almost at the speed of light.
So this cloud is spreading and cooling. What comes next in this cosmic show?
Well, here's where things get really intense.
Okay.
The remnants of the neutron stars, under incredible gravitational forces, collapse to form a black hole.
Wait, a black hole? So we go from a brilliant explosion to an inescapable void? Talk about a cosmic mood swing. But hold on. The article also mentions something about new elements being created in this process.
You're right, and that's where it gets really interesting. All that neutron-rich matter we talked about, that's the key to forging heavy elements.
Hold on. Are you telling me the gold in my necklace was forged in the heart of a dying star?
It's true.
That's insane. How does that even work?
It's like a cosmic alchemy called the R process, rapid neutron capture. Imagine atomic nuclei in that cooling plasma, capturing free neutrons, creating heavier and heavier elements.
So it's like a building game, but with atoms.
Yeah.
Can you give us a specific example of an element scientists observed being created?
In this particular observation, scientists detected the formation of strontium and yttrium.
Strontium and yttrium. Okay, I'll take your word for it.
Yeah.
But I'm guessing the process can create other things too, right?
Absolutely. It's responsible for a whole spectrum of elements heavier than iron, including gold, silver, platinum, and uranium.
So the carbon in our bodies, the silicon in our phones, it can all be traced back to these explosions.
It's amazing, isn't it?
That's wild. It makes you appreciate the universe in a whole new way. But hold on a sec. How do scientists actually see these events happening millions of light years away? It must take some serious detective work.
It does take incredible detective work. And it's not as simple as like pointing a telescope at the sky and waiting for fireworks.
Right.
It takes a global team effort.
So walk me through it. How do they track these kilonovas?
Well, think of it this way. Like, imagine trying to film a movie, but you can only take snapshots from different angles at different times.
Okay, I see the problem. You'd miss huge chunks of the action.
Exactly.
So how do they get around that?
By coordinating observations from
Okay.
telescopes all around the globe.
Okay.
As one telescope's view gets blocked by the Earth's rotation, another one takes over. It's like a giant game of cosmic catch, passing the baton around the world.
And I'm guessing Hubble plays a key role in this game, right?
Ah.
Being up in space, it's got the best seat in the house.
Exactly.
Mm.
Hubble is above the Earth's atmosphere, giving it a clear, uninterrupted view.
Right.
It captures crucial data that ground-based telescopes just can't get.
So Hubble's like the VIP guest getting the close-up shots?
You could say that.
Okay.
It gives us a front row seat to this incredible cosmic display.
Wow.
But the observations don't stop there. Scientists also monitor the kilonova's afterglow for months or even years.
The afterglow.
Yeah.
What can they learn from that? Is there still some action happening even after the main event?
Oh, absolutely. Think of it like the embers after a bonfire. There is still a lot happening as things cool down by analyzing the light emitted. At different wavelengths, they can pinpoint the specific elements created in the explosion.
So it's like a cosmic fingerprint revealing the composition of the kilonova debris.
Precisely. And remember that mention of microphysics in the article?
Yeah, that caught my attention too. It sounds like we're zooming in on the tiniest details of this massive explosion.
Yeah.
What exactly are we talking about here?
Well, microphysics lets us study the behavior of individual particles within the kilonova. Imagine witnessing the very moment gold atoms, the same kind in your ring, were forged. That's the level of detail scientists are getting from studying microphysics.
No way. They can actually see the creation of atoms in real time.
It's incredible, isn't it?
That's mind-blowing.
They can even measure the temperature of the matter at different stages of the explosion,
Wow.
giving us amazing insights into the extreme conditions out there.
It's amazing to think we can learn so much from an event that happened millions of light years away and billions of years ago. It's like a cosmic time machine. But the article also touched on something else that really intrigued me, the possibility of harnessing the energy of a kilonova.
Yeah.
That sounds like something straight out of science fiction.
It does sound like science fiction.
Is that even remotely feasible?
Well, given the sheer amount of energy involved,
Yeah.
it's hard not to let your imagination run wild.
Right. I mean, these events are happening incredibly far away, and we're struggling to get to Mars. So how could we even begin to capture that energy?
You're right. The technological challenges are immense.
Yeah.
It's almost unfathomable with our current understanding.
Right.
But remember a century ago, the idea of harnessing nuclear energy seemed equally far-fetched. Who knows what breakthroughs the future holds?
That's a good point. So let's say hypothetically we could harness this energy. What could we do with it?
The possibilities are almost limitless. Imagine the potential for space travel, powering entire civilizations, or even unlocking new realms of physics we can't even comprehend right now. It's both exhilarating and a little daunting, isn't it?
Exhilarating and daunting. That sums it up perfectly. But even if that remains in the realm of science fiction, just the knowledge we gain from studying these events is invaluable.
I completely agree. It's a reminder that we're all part of something much bigger,
Right.
connected to these events in ways we're only beginning to understand.
This whole conversation has been truly eye-opening. It's humbling to realize that something as seemingly ordinary as the gold in my jewelry has such a dramatic and cosmic origin. And it makes me wonder what other incredible events are happening out there, just waiting to be discovered. We've been talking about these collisions and the discoveries, but what's the bigger picture? Why should we care about these events happening so far away?
Well, it goes back to the idea that everything in the universe is connected. These events, as distant as they seem, have directly shaped the world we live in today.
Can you give me an example? I'm having trouble wrapping my head around that.
Well, think back to our conversation about kilonovas creating heavy elements like gold, silver, and platinum. Without those events, our planet wouldn't have the necessary ingredients for life as we know it.
So we literally owe our existence to these cosmic explosions. That's incredible.
It really is, and it just highlights how important it is to keep studying and understanding these events.
Right.
The more we learn about kilonovas, the closer we get to understanding the origins of our universe and our place within it.
It's almost like looking back in time, witnessing the processes that created the building blocks of our world.
Right. It's like having a cosmic time machine,
Yeah.
letting us peek into the early universe and unravel the mysteries of how elements were formed.
Who knows what other secrets are waiting to be discovered? Maybe, as you mentioned earlier, we'll even find a way to tap into that incredible energy someday.
It's a tantalizing thought, isn't it? But even if that remains in the realm of science fiction, the knowledge we gain from studying these events is a reward in itself.
Yeah.
It expands our understanding of the universe
Yeah.
and our place within it.
I couldn't agree more. It really is a humbling reminder that even in the vastness of space, we're all connected, part of something much grander than ourselves.
Well said. I think that's a perfect note to end on.
So we've gone on an incredible journey today, from the death of stars to the birth of a black hole and the creation of the elements that make up our world. It's been an explosive deep dive into the fascinating world of neutron star collisions. Remember, this is just the beginning. Keep exploring, keep learning, and who knows, maybe you'll be the one making groundbreaking discoveries about these amazing events someday.